All right, well, there's a number of people still trickling in, but why don't we get started? My name is Jason Hendrickson. I'm a senior program manager at Microsoft. I work in the Windows performance team. And I'm actually excited to see how many people showed up for this talk. This is the first time we've delivered a talk of this type at Build. A lot of the talks that we've delivered in the past tend to focus on coding best practices, tend to focus on analysis and optimization of that sort. What we wanted to do with this talk is take a step back and look from the design perspective, starting with design, going into how your code architecture can match that design to start from a good spot in terms of delivering optimal performance. I've been on the performance team for 5+ years now, and when I started there, I basically expected that the entire time we would be sitting there hacking around in the kernel, finding micro-optimizations, working better with CPU caches, and we definitely do a lot of that kind of stuff. But one thing that I didn't expect that we actually find ourselves doing quite a bit of the time, and more as apps become more prevalent, as great user experience becomes more prevalent, is really focusing on UX design. Because UX design, surprisingly, can have a lot of implications on actual performance that's delivered. And even beyond UX design, you can have a decent UX design and have a code architecture, which doesn't match that UX design or the intent of the UX design well enough to deliver on the performance that you want to deliver. So my talk is really going to focus on why is UX design so important, what are some of the challenges that we start seeing, and then I'll move on to 5 key scenarios, talking about launch, talking about resume, page navigation, resize and rotate, those are very similar, and then finally talking about panning. So to get started, I just want to tie this back if some of you guys had attended the talk about an hour ago that Will Sargent had. He talked about the performance journey being this process through which you as developers can go to make sure that you are starting off on a good foot, you're instrumenting along the way, you're testing, you're designing for performance, you're analyzing and optimizing. And I want to tie it back to that to talk about how close to the beginning we are right now. So Will talked about setting up goals. He talked about interaction classes. He talked about time points. He talked about the basics of UI design and iterative loading of content. And what we're going to do is we're going to extend on that. We're going to talk about more nuanced details of UX design, and then talk about how you can translate some of those concepts of user experience design into some aspects of architecture, your code architecture that you can deliver. So while I'm not talking about these later stages, I do want even people who are developing apps and who are really looking for guidance on those apps and how to make them more efficient to really be listening as we go through this, because even though we're talking about starting early on performance can really get you a lot of these concepts can still be applied later on when you're looking at how you can optimize your code paths. The key thing I want you guys to take away, and I'll give a demo of why this is the case. UI design, which is something that typically people think about when they're speccing what they're going to do and develop, it's about what you want to show, but it doesn't necessarily show you how do I want to get there? How can I most efficiently get there? And how can I deliver a great full user experience in getting there? And what I'll show you is I'll show you a demo of an app that I created. It's a simple, silly app, but it gets the point across very well here. That shows you that great performance really does require thoughtful UX design, and then beyond that, it requires thoughtful interpretation of that UX design into actual code implementation. So for my demo, some of you guys saw an actually more advanced version of this, slightly more advanced, that Will presented about an hour ago. This is a very simple app. What it does is it's intended to allow you as a user to go and say, hey, I care about these 10, 15 things, and what I want to see is I want to see the top images for those things. In this case, I've got cats and Le Mans racing as 2 of the most important things that I care about. I've also got finance. My wife had me put on fashion later in this one. So there's a bunch of those things. When the app launches, goes and grabs the images, you can pan around to see all the images you care about, and then you can click to browse to those in Internet Explorer. Super basic, super simple app. But what I want to show you is that even with this level of basicness, it's really easy to get into a condition where you think you're designing for great parallelism and great performance, and you end up delivering an experience that's subpar. So the first thing I'm going to show you is my first attempt at this app. This attempt at this app, as you'll see, it launches, it shows the technology stuff first, and then that moves because really what goes on the first page is cats and Le Mans racing. Stuff gets rejiggered around the UI, and finally you end up with this full set of images that I just showed you on my UI spec. That took about 10 seconds to deliver. And furthermore, because I didn't organize how content actually arrived at the screen, and I didn't think in terms of UX design and translating that to architecture, I delivered an experience that's really variable. About the fastest that this version of the app goes is about 6 seconds to get to this page. And the slowest that I've seen it get is about 12.5 seconds, because content just comes in randomly. I just throw it at the UI, and I deliver on what the spec said in terms of UI, but I didn't deliver on what my performance spec would have said. If you guys were at Will Sargent's talk, he talked about performance specking. So let's look at a second version of this, and I'm going to basically jump ahead and pretend that I've given you the whole talk and apply those concepts that I talked about. I only apply about 50% of the concepts. The delta between this app and the second version of the app that I'll show you was about 1 hour of development. And what you'll see here when you go to this app, launches, it's ready within 2 seconds. And this is super consistent. I run this 50 times, and some of the time it goes a little slower than 2 seconds. Some of the time it's slightly faster than 2 seconds, but it's very consistent in getting up there pretty fast. Now, this isn't as fast as I would want it to go, but this is a great starting point for my app. So from that starting point, I could then go and analyze the code. I could look for opportunities to get it down to the 1 second that I really want to target. And there are definitely opportunities here. If you were at Will's talk, he pointed out one of the opportunities, a network round trip. But this is a lot better than what I showed you before. And this is a lot better starting point. So because early on in my development, I've already gotten to the point where I've designed with UX best practices in mind. I've designed with some of the architecture best practices I'll talk to you in mind. And I've started measuring early. I'm in a great spot where I can iterate on this app and not regress from that 2 seconds. And I can keep delivering a greater and greater user experience as I add features to this app, but still maintain this user experience. So I mentioned I just skipped ahead to the end of the talk. OK, let's rewind a little bit. I'm going to talk about differences between these two apps first. What I did for these two apps is I prioritized the first page of content. Very simple in concept, but actually in execution, we find that a lot of people think that they're prioritizing the first page of content, and then some asynchronous work items sneak in, some timeouts sneak in, and they're actually doing a bunch of work that they don't need to do just to get that first page of content in. So I'll talk about tips and tricks for how you can make sure that you are absolutely prioritizing that first page of content to get it up as quickly as possible. In this case, I kicked off, instead of 10 asynchronous network queries, I kicked off 2, because that was what was needed for the first page. And I made sure that my content always hit the screen in left to right ordering, so that I didn't need to move UI around. Pretty simple, but I made sure I did that from the start. The second piece is about images and caching. The first example I gave you gave the same UI as the second example, but what we've seen a lot of developers do is choose to use whatever the highest res image is that they can find, because they know that that'll deliver the highest quality. What I used for my second version, looking exactly the same, is just thumbnails that I got from the Bing image search query. And those thumbnails also are thumbnails that were from an HTTP server that specified the right headers so I could cache that content. And that's how I delivered some of the consistency of getting the app to show up with images in 2 seconds. I didn't have some complex local cache for these images. I just made sure I was pulling the images from the right place and they're the right size. And then finally, I made some optimizations to how I use the splash screen and animations around launch. I'm actually going to defer talking about that one until we get to the launch scenario, and I'll come back to this. So those were just some things I did. What I want to do is take that back from just a set of things to make it more kind of codified, how you can actually approach designing from scratch so you can hit the kind of performance that you want. So this will talk about what are 3 challenges that people hit consistently, regularly. We see it all the time. And again, my full-time job is performance, and so we see this all the time. We'll talk about some UX design best practices that you can start with, convey the UX appropriately to developer, if you're a UX designer and developer all in one, but just listen to all the steps. And then some development best practices where you can turn this into an actual architecture that will deliver great performance. So the first challenge is multiple pages of content, and a really easy example of that, again, is that app that I just showed you. It shows only one screen at first, but if you flick to the right, it'll show a bunch of content. Tons of apps are developed in this way. A lot of people have multiple pages of content in their apps. And the challenge here is really, when I tie that forward to scenarios, it's really going to affect how you guys work on your page navigation as well as your app launches pretty significantly. So the design, of course, you want to deliver more than can fit on one screen at a time. The reality of it is, if you don't organize loaded content, you get a slow, jittery UI, and you guys saw that in my demo. So let me go through a couple apps that have done this pretty well, and I'll talk about the different mechanisms they used. So the first is this SkyDrive app. This is in Windows 8.1. You saw there I clicked the back button, and immediately it had content ready. Even though I have hundreds of albums here that it's going through, hundreds of artists, I click the back, split second, it's ready. It has a lot of content, and this app happens to use the list view. And it can happen to deliver great experience because the list view helps you to actually deliver just that first page of content before delivering any other content. So list view is a great tool for delivering just the first page of content and making sure you get that first page responsive first, so that the user doesn't have to know, yeah, there's these other pages you're loading in the background. All they see is great UI and great responsiveness. Let's look at a little bit more complex example, the finance app. And what I want you to watch out for at the bottom of the screen is that scroll bar. You see the finance app launch, you see it get to a good state pretty quickly, and you see that scroll bar at the bottom growing. Now, if I hadn't moved my mouse down there strategically during the video capture to make sure that I had that scroll bar showing, the user would be none the wiser that the app actually is doing a ton of work in the background to load up that second, third, fourth page of content. There's a lot of different things that this app does, but the app gets to be responsive very quickly within a couple seconds, and then the user can start navigating around that. And these are the kind of techniques that people use to make sure that their app, that's a rich app, that flows, that has a lot of content, can actually deliver the responsiveness that users want, but also deliver this kind of richness. It starts with design, and this is super simple for most people. Identify the required UI for the first page. I guarantee you the next couple challenges will be more complex than this, and so I'll get to something much more useful. But even in thinking about this, if your design at the design level is already complex enough that you can't actually call out for sure what content you're going to have on the first page for a user, you might want to see, can you simplify that and still deliver a good user experience? Because if you can't define what UI you need, your developer is going to have a really, really hard time making sure that they can code just to deliver that first page of UI and then delay load all the content in that they need. From a developer perspective, again, I pointed out the SkyDrive app because it uses virtualized lists. The idea behind virtualized is that the framework itself knows, you know what, you may have thousands of items. It knows that. It allows the user to start panning across those. But what it does is it makes sure that it makes real, it makes concrete, only that first page of content first, and then a couple prefetch pages of content, and it schedules work to make sure that the UI is in front of the user and that it's the right UI in front of the user, even when you have thousands of items. So even if you're using virtualized lists, you might be doing a bit of code execution up front. And one of the things that I encourage you guys to do is develop only for that first page of UI to be responsive. And this seems like a super simple step, but I mean it when I say like literally develop only for that first page of UI to be responsive. And let me turn this back into concrete terms in terms of the app that I just showed you, my app. I thought I was being smart. I kicked off 12 asynchronous requests, and I made sure I kicked off the asynchronous network request for the content for the first and second page. I made sure I did that. So I thought that I was developing at first for the first page of UI, but what happened is that these things come back in random order. When different parts of rendering those additional pages came and started executing, they executed in random order, and I ended up with an app that was way slower than when I explicitly kicked off 2 network requests, because that was all I needed for the first page, and when I explicitly put only those elements into the UI that I needed. What we've seen time and again is that people think, I'm going to develop for that first page of UI to be responsive, and what ends up happening is that because they've just said, I'm going to defer additional work, but not recognize that the async nature of the WinRT framework makes it so that deferred work may run ahead of some of the asynchronous work you kick off, that really you're not scheduling the work appropriately. Really, you're not developing just for that first page UI to be responsive, and really you're executing a lot of code and adding a lot of UI elements you really didn't need to add. And this can add seconds of time. I mean, what you saw in my app is it added seconds of time just by not prioritizing that first page first. So let's get this a bit more concrete. Let's turn this into code. So first of all, for virtualized lists, I'm not going to dig into that too much right here. There's a lot of great content on XAML and HTML list views and grid views. There's a lot of great sessions. There's sessions for XAML list and grid view at 5 o'clock, parallel to a session for HTML, the WinJS framework, including the list view and grid view, again, at 5 o'clock today. So I encourage you guys, if you're interested, go and attend those talks. One key note here is that constant size items, if you use the virtualized lists, that's preferred. That can be much more efficient. And if you can't use constant size items with the list view or grid view controls, look at some of the other controls that have been added in Windows 8.1. Look at the hub control and see if you can use that, because that may be more efficient for your purposes. In terms of scheduling work, because that was one of the key pieces that I wanted to get across to you. Scheduling work, so rather than in HTML, some of you who are HTML app developers may have used set timeout or set immediate to say, you know what, I don't need to execute work right now. I'm going to defer. Anything else that needs to run, it can run ahead of me. The WinJS scheduler gets much more concrete than that. This is, again, new for Windows 8.1. And this allows you to define, you know what, this item I need to get done, this work item I need to get done for the first page UI, I'm going to define that as a high priority work item. These other work items, I'm going to queue up. but they're really meant for the second or nth page of content. I'm going to define that as an idle task. With the WinJS scheduler, you can get much more concrete and make sure that you don't accidentally kick off work for the second or beyond page of content too early. And you can get a great responsive experience as a result. For XAML, you can kick off async operations and longer async operations to prepare a bunch of data, then post back to the UI thread. Again, making sure that you're not adding a bunch of UI for those nth pages of content before you've added that UI for the first page. And then finally, collapsing content. This is something I didn't touch on the previous slide, but was mentioned on the previous slide. As you're building up your UI for your second page and beyond, the user doesn't see it. But even though the user doesn't see it, if you throw the elements into the DOM tree or the XAML tree, you're adding some costs on the UI thread. You're causing CPU work to be performed. And you can minimize that CPU work by making sure that the elements you add do not affect layout at all, do not affect display or rendering at all. And these are the ways you can do it, with a display none style in HTML or CSS, and with a visibility equals collapse in XAML. Once you have a bunch of that content ready and you're not going to modify it anymore, then you can pop all those elements to be fully visible, and those will all be efficiently rendered in the UI by the framework all at once. So this is a great tool to build up UI without having it cost you an extra lot of time when the user's not going to see the benefit of that. So that's challenge number one. It's a relatively simple challenge because you can identify the first page of content pretty easily. These are some scheduling constructs. I want to go into something that talks about a bit more rich functionality. So this challenge here, this is one that I'll actually be referring back to for 4 of the 5 scenarios that I'll talk about. App launch and page nav, that's something that you guys are immediately going to jump to the conclusion, like, yes, I can apply this there. When I start talking about resize and rotate and panning, I'm going to tie back to this, because what this one's all about is if you have rich visuals, regardless of the goals that you have, rich visuals and rich functionality can sometimes cost. And what we've seen repeatedly is that people want to throw stuff on the screen. If you're prioritizing just your first page of content, it still may be a very, very rich first page of content. And you might be able to get your UI up a lot faster by deferring some of that work, or by making the way in which you put UI up a bit more optimal. So let me go through a couple examples here. The first example I'm going to go through is the Music app, the new Music app for Windows 8.1. So as I launch it, watch what happens on the left and top. There is content that appears. It's pretty static content that appears there. It's navigation content that appears. And then the more rich, complex elements of the music library, those are deferred loaded. So by the time that the navigation elements show up, the user can already orient themselves in the app. And the user can already decide, you know what? Yeah, I know this launched to the albums collection, but I really want to search by song name because I don't know what the artist name is. They can start with their path towards navigation, and the deferred loaded content, which is really rich, which the user may want immediately, that can be deferred loaded so the user can, again, get an experience that they can navigate, a responsive experience, and then a little later can get the more visibly complete experience. Now let me go back to the Bing Finance example, because that one also provides some really good context. The Bing Finance case, you probably weren't looking for it before, but look in the top right corner. So when we go here, it launches, and UI appears, and you see that search bar appear just a little bit deferred. And as you scroll across, also, you see there's a lot of different functionality. There's this stock trends chart, there's tickers, there's news articles. These are all different pieces of functionality, where if in this app they decided to load up all their code for all this functionality up front, then that can take a lot longer. Instead, if they defer loading both pieces of UI and code that can be complex and costly, then you can get to a much faster state. So great, so we've talked about just a couple concepts of deferral. I want to, again, make this much more concrete in terms of steps that you can follow. The first step as a designer, taking a step back from all that scheduling stuff we talked about, is code for UI. Let me describe what I mean by this. You can build up your UI by having a bunch of JavaScript or C# or C++, add elements to your visual trees, your DOM tree, your XAML tree, and you can definitely get a UI that way. But what that generally ends up doing is making it so that the framework is much less efficient. Rather than having stuff statically defined and having it be able to do one kind of really efficient layout pass, you're forcing it to potentially do multiple layout passes. As a designer, you can take a look at your design and say, am I delivering a design where there's going to have to be a lot of code backing this? And you can talk to the developer and say, like, can you actually deliver this as a static chunk of HTML or CSS or a static chunk of XAML? Or are you going to have to do a lot of work to relay out elements depending on screen size manually with code? The most efficient designs that can be delivered are going to be those code-free designs that really leverage the capabilities of the frameworks to dynamically position elements without code having to run, or without your app code having to run, of course. The next step is identify distinct functionality. So with the Bing Finance app, in their UI spec, they probably had that full first page of UI, including the search box. But the designer and developer can work together and say, you know what? What I really, really, really need is just that first article to appear. I don't need the rest of it. And then if the designer can identify these are the specific elements that I absolutely need, the developer can go and say, okay, well, I'm going to deliver, again, going back to that first page, I'm going to deliver only those elements first and then defer load everything else. And again, as a developer, you can get smarter about this. Once you've delivered a great experience, you can see about pulling things back in and see if it costs you. But then you'll at least have a great starting point. Once you've identified that distinct functionality, as a designer, you can, again, design for multiple stages. What's the first stage of UI you want to show up? What does it look like next? And then usually a third or fourth stage is what's the prefetch that you do on these next pages. I'm going through this laboriously right now, specifically because we've often seen people skip these steps. And when you skip these steps, you're losing a bit of communication about what you want your user experience to be. And often people don't develop in this manner. So we'll get to in the development portion how you can turn this into actual development. The last piece I want to talk about for design is animations. One of the things you may not have noticed, or I mentioned very briefly about the app that I delivered, that 2-second app, the reason it was 2 seconds instead of closer to 3 seconds was because I killed animations out of the splash screen. I said, you know what, I have the splash screen, it's going to fade out, I don't need to animate this content in and block the user experience. It's right there, ready, and it's been snapped to. If you're delivering a user experience design and you want it to show up in 500 milliseconds and you have a 1-second animation, you've already failed. So that's something to take into account from a design perspective. From a development perspective then, architecting for deferred loading is very important. Now here's what I mean by this. This isn't just that you design your code such that you load UI elements, one after another or something like that. This means that basically if you have a piece of UI you need to show, and you have to load 90% of your code just to get the first 10% of your UI, you're not architecting for deferred loading. You have an architecture that has to load an entire framework in order to get to that first frame of real UI. And if you've designed for that, and we've seen this all over the place, a kind of tangled architecture where you have to load in most of the framework. If you've designed for that, that will generally result in a slower app launch or slower page navigation. So making sure that you've architected such that when you load the UI, you can then load the code backing it is a great way to make sure that you have a really scalable UI and that as you build on your user experience, you're off to a right start. The next piece as a developer is developing large chunks of static HTML and XAML. Now this isn't to say that your HTML, CSS, XAML, these shouldn't scale with the screen size, but as much as possible, if you can develop, again, using large chunks of static HTML and XAML and load those in batches, that's going to deliver a much faster experience than if you have to programmatically create little elements here and there. As a developer also, making sure that the elements that you've created in your UI actually match one-to-one with the design that you're given. That's very important. So let me give just a little example here. Say you have a toggle switch. It just toggles between on and off. All it does is change the text and the text color. You can develop this by creating 2 elements, one that's hidden, one that's visible, and you just change the visibility of those. That'll satisfy the UI design. That'll be perfect. The problem is you've just taken an upfront hit to load time because you've created 2 elements. If instead you just updated the text and color when the user pressed that, you've got into a responsive UI a little bit faster, and you've delivered the user experience you want anyways. Now that's just one example. If you have one control that does that, it's not the biggest deal. But what we've seen is a lot of people will throw a bunch of XAML elements or HTML elements at the screen, hide a bunch of them, and then change these kind of visibilities or have progress bars in the background that can't even be seen, delaying rendering of things. So making sure that you've actually developed so your elements match one-to-one to the UI design, that's going to be a great way of making sure that you've delivered something that, again, is as responsive as it can get. And the final piece, which I'll just wait till the next slide to talk too much about, is efficient images and animations. So I'll come back to that in just a second. So the first piece I want to harp on again is programmatic layout versus depending on the frameworks for layout. What we've seen time and again, especially in the HTML space, is that people like to ask, where is something? Like to ask, where is something? And then like to position their next thing based on it. If you're asking where is something, you've just asked the framework to lay out your page, give you a precise set of coordinates, and then you're about to just go and dirty those coordinates anyway by inserting additional elements. So what you've asked it to do is a layout pass that is going to be used for nothing else. Instead, what you can do is you can make sure that you don't have to ask for that positioning. You've positioned using HTML and CSS, and you can get that UI that you want in one layout pass. Be much, much, much more efficient. We're talking, we've seen seconds of savings by shaving out the need to programmatically position objects. So I promised I'd talk about images and animations. We talked previously about the right sizing of images, making sure that the images that you download or the images that you show are the absolute right size for the UI you want to deliver. This is important for two reasons. One, if you're getting the images off the web, obviously, number of bytes transferred. That's important. Two, there's CPU time associated with the images. And again, this is something that many of you may already be doing, may already be aware of, but it's very important, if you can, to get the right size image. And if you have a local image, GetThumbnailAsync is a great API which will do that scaling for you and use cached images for a lot of the UI you want to show. And then from an animation perspective, I'm not going to talk about independent animations here, but many of you may be familiar with that. If not, I encourage you to go read up on independent animations. The idea there is you let the framework or the OS deal with animating every frame for you. You don't have to be asked on the UI thread, hey, so what's my next frame going to look like? Okay. And this has two benefits. One, it makes sure that you can deliver 60 frames per second with your animations because the OS is the one that's efficiently doing that. And two, it makes sure that you're not delaying other user operations by being asked every 16 milliseconds, where's the positioning of my next content? So again, static CSS can get you that. WinJS animations will get you that. And for XAML, it's actually really easy because by default, it won't do dependent animations. It'll always do independent animations. So as long as you're using theme transitions or animations, you're going to get independent animations. Finally, I want to talk about deferred load. And this goes back to the concept. When you're showing UI, have the code backing it be loaded at the time that you show the UI. And we'll talk about some nuances of this in the page nav scenario, but especially in the load scenario, the launch scenario, this is very important. To do this with XAML, it's pretty simple. Use custom controls. You can put XAML content in there, and you can put code in there. Your code won't load until you insert the content, and so you can iteratively load both XAML and code by doing this. With HTML, it's very similar using WinJS fragments. These are chunks of HTML where you can put DOM elements in there that are actually going to show in the UI, and you can also put script tags and CSS tags that don't need to get loaded at all, don't even need to get parsed until you decide, aha, now I need that piece of UI, so I'm going to load that in. And again, this is the kind of thing that when we look at it, often loading code for one piece of functionality doesn't take that long. When you've got dozens of distinct pieces of functionality, which we've seen many apps have, this can add up. And this adds up to, if you don't develop from the start for using deferred loading of distinct chunks of functionality, and again, 2 to 4 distinct chunks is a really good number. If you don't architect from the start, we've seen people get into cases where they just have a tangled web of very, very, very small code paths, and it's very difficult for them to unwind that and figure out, okay, how do I get back half a second worth of time? Because you're going back through your code and figuring out, what can I defer? Okay, I can't defer that, I can defer that. So doing this from the very start is going to get you the biggest bang for your buck. So I want to move on to challenge number 3, and then we'll move on to the 5 scenarios. Challenge number 3 is a bit different than the previous 2 challenges that we talked about. The previous 2 challenges really focus on efficiently getting UI up and also making sure you can defer content that's absolutely not critical. This challenge really focuses on live content. So a lot of you guys are developing apps where you want to deliver the latest and greatest from the web. If it's a news reader, that's great. If it's something that shows what's on someone's movie queue, for example, that's great. And getting what's latest and greatest on the web to a lot of people means going to the network immediately. The reality of it, however, is that if you go to the network can be slow. And I don't just mean network can kind of be slow. I mean that we've seen this delay apps by multiple seconds. You get very variable launch times. The user can't necessarily predict what they're going to get out of launching your app. And on average, your app is going to be a bit slower. So I want to go to an example of an app that's done this really well, that's dealt with fresh content, but also launches very consistently fast. And the app I'm going to use is the App Store in Windows 8.1. So what I want you to focus on here is on the left side. There's a flipper control here. This content, the second you launch it, is potentially stale. It's potentially cached. But what's happening in the background is that network request is going out. The user's none the wiser as to whether this is stale. But right here, when it transitions to that fourth piece of content, if it's got new, fresh content by then, it naturally has transitioned the user from looking at that stale content into looking at fresh content. This is the kind of UX design that really you can't replace with great development practices. Unless you have a UX that naturally transitions from cached content to live content, you can't code your way out of it. This is one of the 3 challenges that really requires great UX design forethought. So I want to talk about, again, how to turn this into kind of a pragmatic step-by-step solution that you can think through. It's not particularly long, not particularly taxing, but from a design perspective, the first thing you'll want to do is identify your freshness goals. So a lot of you are probably saying, you know, I want to deliver the latest and greatest from the web. That's great. Does that mean up to the second? Does that mean if the user launches your app and sees something that's an hour old, it's okay? A day old? A couple days old? Understanding that is key to making sure that if you can develop for cache content, that you do. Once you understand your freshness goals and are really, really crisp about those, and these mean what's the min bar that a user can deal with in terms of how stale their content is, then you can move on and you can deliver two sets of UI. One, making sure that you've designed UI for cache content where possible, and for the paths where you won't be able to have cache content, making sure that you're not sticking the user, for example, with a spinning donut, just waiting for anything to show up on the screen, but give them at least the skeleton of the UI that you want them to deliver, so that they can know, yes, my app is responsive, it's maybe loading individual pieces of content, but I can at least get myself oriented within this app. So there's two paths of design here, but one of the critical pieces is making sure that if you have cache content, which again, we'd strongly encourage, you have a smooth transition from that cached to live content. That's what you saw out of the Store app using the Flipper control. You saw that smooth transition. Frankly, users none the wiser as to whether there's cached content or whether there's live content, because they're probably not going to remember, hey, you know what, I saw this app 2 days ago. What happens, though, is that the user gets that live content naturally and very quickly the second that it's available. So the user can navigate around the app, and naturally, they don't even know that they're being fed live content when they are. From a development perspective, obviously, from a developer perspective, you want to cache the content. We've been talking about caching the entire time. On the next page, I'll talk about some APIs you can use, but cache content. The piece you may or may not be considering is, even as a modern app that gets suspended when you're not in focus, you can still prefetch content. Even if your app has not been used for a week, you can potentially prefetch content so that when the user comes back to your app, you can be much more fresh. And this is one of the great ways of achieving whatever freshness goals you've specified. Because when you prefetch that content, you don't have to be worried necessarily that, oh man, the user hasn't used my app in a week, so I can never be guaranteed that they'll achieve freshness goals, so I'm just not going to develop for cached content. You can be a lot more confident in developing for cached content. Choosing the right control is obviously important. You've got to work with your designer to make sure that the smooth transition that they've planned from the cached to live content is something you can develop. And then finally, as a last step, optimize. And I put this in as a last step because, yeah, there are probably going to be some paths that you have to go through that have that live content and you can't use the cache content or your caches aren't built or anything like that. And only after you've designed for your UX and only after you've designed your architecture for that cache content, that's the point at which you can think about, okay, how do I optimize this? It's still a critical step. You still want to reduce the number of round trips that you have. You still want to reduce the number of bytes sent over the wire. You still want to parallelize. But it's at this point that you want to get to that. So from a coding perspective, let's talk about a few cache implementations, and we'll talk about the Fresh Apps feature. So for HTML, if you're developing an app with HTML, you can use the app cache. This will go and get resources for you to make them available offline. I encourage you to read up on that if that's interesting. For anything that goes over the web, you can use cache control headers to make sure that your content can actually be cached on the client side for a reasonable amount of time. And then using the right APIs will make sure that you're pulling from the local cache such that when the user comes back to an app the second time, yeah, your APIs still think they're going out to the web, but they're actually going to the cache, that's how I deliver the consistent 2 seconds of performance in the app that I showed you guys. And the third piece is, obviously, everyone's probably implemented a custom cache at one point. You can do that, of course, with WinRT. Your local folder will get you access to the local file system, and local settings will get you a structured set of settings that you can have cached. The Fresh Apps feature is where you start getting into prefetching content. So in Windows 8.1, a new API was developed, the content prefetcher. This allows you to specify that there's a set of resources you're going to want to be updated regularly, or specify a URL that you can go to, that the system can go to, which then points to other URLs for content that, again, you're going to want to be cached locally. This then goes back to the cache control headers. Make sure you have the right HTTP headers on there. Make sure you're using the right APIs. But this will make it so that when you request those content from the web, it's already been pre-cached for you in a lot of cases. And the OS will decide when to pre-cache this, so it's really efficient for battery life. And for frequently used apps, you'll get a lot more fresh content by doing this. And if you've implemented a manual cache, or you can't use a content prefetcher for any reason, then again, background tasks can be developed. You can run your own app code as long as you're using the maintenance trigger. and the app code will run and populate your cache. This will happen at a time that's, again, efficient for the user. When they're idle, when they're on AC, things that aren't going to impact battery life or responsiveness. So this is how you can get to that cached content, but still remain pretty fresh. So I'm going to take a quick breath and then move on to these 5 key scenarios. A lot of the challenges we've talked about will apply directly to launch and page load. So I'm not going to rehash those challenges if they apply directly and obviously. But what I am going to do is talk about some of the nuances of each of these scenarios so that we can talk through additional opportunities you have or ways of applying some of the solutions to the challenges we talked about in unique and interesting ways that you may not have thought about. So for app launch, again, challenges 1, 2, and 3, we all talked about those. We all can see how those will apply to app launch. So what I want to talk about is a couple interesting nuances of app launch that you may not have thought of. One of them is a splash screen. While the OS splash screen is up, the UI frameworks that you're developing on can know, I don't actually need to render anything because I'm completely occluded. And so while the splash screen is up, you can save CPU time by leaving the splash screen up for longer until you get to a responsive state, that first stage that your UX designer has specified. That's what I did in my app that delivered 2 seconds of responsiveness. You can defer the splash screen even beyond your activation handler to make sure that the splash screen will stay up for longer. Some of you have used the extended splash screen. This doesn't accomplish the same effects because the extended splash screen is actually a piece of UI that you as the app owns. And so your app framework will still say, OK, now I'm in focus. Now I need to go and do the extra rendering work for every frame. So don't use the extended splash screen unless necessary. Again, some of the concepts we talked about in Challenge 3, if you follow those, then you'll be developing a user experience that doesn't need a bunch of time to load up. It'll have cached content locally, or you'll have developed for a skeleton of your app to come up before pretty early, and so you don't need to use the extended splash screen. But it's there if you need it. And then finally, you can disable animations. This, again, is somewhat of an optional thing. Animations won't necessarily add a bunch of costs to the UI thread because they can be independent. The OS can do those for you. But what it will do is potentially give a perception of faster launch. The splash screen already has a fade-out animation to your app, so why have that second animation? This is a lot easier to disable across the board with HTML than with XAML, because with HTML, if you're using WinJS animations, you can wholesale disable those. With XAML, you'll have to go and manually remove animations or add them back. But it's something you can consider doing if you want that extra little edge on your app launch performance. So another key differentiator is the launch contracts. So if any of you have developed an app that uses, that can satisfy picker requests, that can be launched from the share charm. Some of you are familiar with the launch contracts. But the idea is, going back to challenge number 2, if you're going to show a different UI for these different contracts, why bother loading up some standard single page of UI or single HTML or single class in XAML that you want activated, and then deciding, oh, I'm going to go down this code path, I'm going to go down this UI path. In Visual Studio, you can use the start page or entry point constructs in the Properties tab. And you can say, you know what, for picker, I'm not even going to load my main HTML, I'm going to load my picker HTML and other things like that to make sure that, again, the code you're loading, the UI you're loading, is one-to-one mapped to the user experience you want to deliver, and you can get that done super fast. So I want to move on to Resume, because, again, launch, challenges 1, 2, and 3 we talked about, and those directly apply, so I don't want to harp on that one for too long. For Resume, it has a couple key differentiators, and this is where challenge number 3 really plays in a ton. 1, when the user swipes in for the last app, you have a cache snapshot of your app. And 2, memory management plays a key role in Resume. Because you have that cache snapshot, you really need to design a great transition to live content. You will, by default, have a case where you have a cached view of your app, and the user is going to see that. And if you decide to relaunch or reanimate your app, just because you've been resumed and because you have some content that's maybe stale, the user is going to see that as jumpiness. They're going to see that as slowness in the resume path. And so as much as you can, delivering a transition, a great transition from the cached images and cached content there to very live content, that's going to give you an edge in this scenario. And if you can do that for this scenario, you can probably do that for launch. So I'd encourage you to think in terms of, can I deliver a great experience on Resume even with transition to live content, and does it carry over to launch? From a memory management perspective, the reason I put this here is because, yeah, memory is important while your app's in use. If anyone attended Will Sargent's talk this morning, it's pretty clear that you can affect other apps' performance. But memory really plays a key role in resume times. The working set of your app is something that the OS will look at and say, you know what? If you're in the background, you're suspended, and you're the biggest app, you're going to be the most likely to be swapped out to disk to make room in physical RAM for other apps. And if the OS needs to actually kill an app to reclaim more physical memory or on-disk swap space, then you're going to be the first target of that because your app decided it's not efficient. So reducing working set will make it so, A, your app resumes slower. A lot of systems can deliver something on the order of 60 megs per second of sequential read time. And so if you're a 300 meg app, then that's 5 seconds of resume time there if you've been swapped out. And again, if you're a 300 meg app, you're likely to be the one to be chosen to be swapped out. So reducing your working set can make it faster and can make it so you resume more often instead of being relaunched. I want to talk about a few best practices here around leaks, because we've seen this a lot, and we've seen people unintentionally use a lot of memory. Leaks are obviously something everyone wants to avoid, but here are some things that people have run into with the UI frameworks and the code that's backing those for both XAML and HTML. Event handlers are a place where people often add, but don't necessarily go back and remove. And if your event handler has references to UI elements especially, or other code or other objects, then that's a place where we've seen leaks. Visual elements, holding on to those as you navigate pages, that's something that, again, we've seen, where you've navigated a page, no one's ever going to see that UI again, but because you've got a piece of code that's referring to a piece of UI, again, it leaks. And this can be on the order of megabytes per time that happens, so this can be really bad. And then create object URL. This is a call in HTML that unless you use a one-time only flag, it'll hold on to that, the resulting object forever. And we've seen, again, cases where HTML apps not using this, they continue to leak. So these are 3 ways that people accidentally introduce leaks. Another is by using hybrid JavaScript and C# apps. So this isn't a hard don't. This isn't something that you can't do. Obviously, it's something that's an option that's available to you. But this is a place where we've seen it especially hard for people to track down leaks. JavaScript object refers to a C# or .NET object. That object refers back to that same JavaScript object. Normally, a single garbage collector could detect the circular reference. 2 garbage collectors can't. So we've seen people introduce leaks and circular references here, and it's easier to do when you're doing a hybrid JavaScript and C# app than if you're doing a hybrid JavaScript C++ app. So consider whether you want to get into that. Finally, these are just tips and tricks. Visual Studio has some great memory tools that they've introduced recently, and I encourage you to check those out to look at how much memory you're using, how to diagnose that, and how to reduce it. And there's a great talk, I believe, tomorrow on Visual Studio that Jonathan Carter's delivering. It's in the references here, if you're interested in that. So I want to go on then to the page load scenario. So the page load, resume, app launch scenario, these are the ones that are really kind of directly play into challenges 1 and 2 and 3. When we get into the other scenarios, the rotate and resize and the panning scenario, they play into challenge number 2 in less obvious ways, so that'll be very interesting to look at. From a page load perspective, key differentiator versus launch, you have similar types of things you're going to do. You're going to want to have complex UI. You're going to want to have code that you load. But a key differentiator is that there's no OS-owned animation. So you need to provide those animations. You need to provide responsiveness at different time points. And just as best practices, here's what you can do. To give a great first response to the action, immediately kick off an animation to animate page out. And then after you've kicked off that animation without delay, then you can start preparing that content off screen, like we talked about, collapsed, so that you can build up the UI in an efficient way. The time frame you want to be looking at here, if any of you attended Will Sargent's talk, is the responsive interaction class. This one's got pretty tight goals, 500 milliseconds to 1 second. And this means you're really going to have to apply a lot of those concepts from challenge 1 and 2 in this scenario. And then finally, your deferred load content, like we talked about already. Many of you have thought about this and said, well, I'm running code before people have navigated between pages in my app, so I'm just going to prepare content in advance. That can be a great thing, but you don't want to overdo it. We've seen cases where people do overdo it, and then you have a bunch of memory bloat. Then your app resumes much slower. Or people overdo it, and they're doing a bunch of CPU or GPU work and interfering with operations that the user wants to do on the current page. So you'll want to do this only for high likelihood operations which you're, 90% sure the user is going to execute, rather than doing it for every single page under the sun that you can think of. You'll always want to measure the impact. So again, using the Windows Performance Toolkit or using Visual Studio to look at the CPU and memory impacts is going to be very important. But here's some do's and don'ts that are kind of general, kind of hand-wavy. But you can think of, here's the types of things that you'll want to do and not want to do. For network content, as you guys know, yeah, that can take a while to load up, especially if it's only a few hundred, a few KB, a few hundred KB, and this is something that you can efficiently cache locally without bloating memory. go ahead and do that. If there's pre-calculations that require a lot of CPU work, especially if you can do it on a background thread, and you can cache it locally without a bunch of memory impact, go ahead and do that. And if you need to load code, this is the one exception to the load code with your UI, as long as you're doing it deferred and as long as you measure the impact. Code can be hard because when you're loading code off the disk, sometimes it requires seeking around the disk a bit, and it can introduce some additional times. So if you're loading code, that can be good. Just measure the impact. The one thing I want you to walk away with is don't pre-populate the UI for those additional pages, because this can really, really, really bloat memory. Those UI elements can be very costly, and if you're doing this, you've got to make sure to measure the memory impact, or else you're setting yourself up for really slow response times and to be killed instead of resumed. So like I mentioned, these three were some of the more obvious scenarios, some of the more obvious pieces of guidance based on challenges 1, 2, and 3 that we walked through. Resize and rotate is very interesting because it's different in that it has distinct timelines, and if you don't hit those timelines, unlike your other scenarios where you just don't feel responsive, in these cases, you'll be cropped. Your UI will be cropped if you don't hit these timelines. For resize, when you grab the app and move it over, you got 200 milliseconds to complete a set of work. 200 milliseconds. That's one of the tightest timelines we've talked about so far. For rotate, you have 400 milliseconds if you queue up work asynchronously because you've unblocked your UI thread. Or you have a couple hundred milliseconds of grace if you do all your work at once, but we encourage you to think of 400 milliseconds as your target for rotate operations. So let me just show you really briefly what it looks like if you don't hit those timelines. You have your app in landscape. You go to portrait mode, and you see a cropped version of it with the background color seeping through. Not a great user experience. This is something that looks the worst the longer time it takes, and your UI is completely unresponsive during this time. And then finally, once your UI is ready, it'll fade into that new set of UI. So I mentioned that challenge number 2 really plays a key role here because, again, the best thing you can do is use XAML and HTML inbuilt features in order to make this go fast. The Visual State Manager can translate elements or properties on your elements really efficiently. If you define using the Visual State Manager another state, it can do a single layout pass really efficiently and get you into a resized or rotated state. And likewise with HTML, if you use HTML and CSS to do your positioning, instead of doing manual positioning with JavaScript or loading of objects, this can be a lot more efficient. Where those 2 tips don't get you to fast enough, just like we talked about with challenge 2, with page navigation, deferring expensive work, you can do the exact same thing here, but you want to do that on a much tighter time frame. So let me give a couple examples. Here's a snap operation, and the performance of this will be similar to the resize operation. And that handler took 150 milliseconds, and it showed the UI pretty immediately in the right spot. So that one's great. Let's show you one that takes 500 milliseconds. As this gets snapped, it goes cropped, and then it transitions here. So it's up to you to decide whether or not that's a user experience your users want to see, but it is definitely one that's not optimal. And the longer it takes to get to that snap state, the worse it is for your users. Now let me show you one that takes advantage of challenge number 2's solutions, where a UI designer can go and say, you know what, I want to show just that title first to make sure I'm positioned in the right spot, and then fill in the rest of the content as I go in. This will address the being cropped. You see it goes to the right position, and then it deferred loads the additional content. So you get out of having that really choppy, cropped UI, and at least get your content in the right position. So we encourage you to try to hit the timelines, but if you can't, take advantage of some of those solutions from Challenge 2. Finally, I want to talk about panning. So in the previous slide, we talked about getting to much more tight time frames, 200 to 400 milliseconds. In this one, you've got even tighter time frames. You have real-time loading of objects. Potentially, you got 10,000 items in your list, and the user's going to pan like this, and they'll pan for something like 3 to 6 pages per second. That's what we've seen users do when they're trying to pan pretty quickly. If you have, say, 20 items per screen, and you want to plan for 5 pages per second of panning, you have 100 items you want to render on the screen per second. That means you have 10 milliseconds to complete each item's work. 10 milliseconds. That's much tighter than the 200 milliseconds even that we talked about in the previous slide. 10 milliseconds can be hard. Going back to the concepts of Challenge 1, some of you may be thinking, okay, well, I'm just going to preload all that content. It'll make panning fast because I don't have to do any work. It'll just be the HTML or XAML frameworks doing it for me. But that'll impact your page load time, so we do suggest you use the virtualized lists. What you can do is just like challenge number 2 suggested, use minimalist templates. Make sure that you have very low number of XAML elements, very low number of HTML elements, and you can do things as optimally as possible. But often that still doesn't result in the richness of UI you want to deliver in the time frame you want to deliver it. So again, this goes back to challenge 2, breaking apart your UI per item into what's critical for the user to see as you're panning versus what's not critical, and what can be delay loaded. Let me give you an example of this multi-stage renderer. And by the way, there's 2 talks. Again, these are happening at 5 o'clock, and these are parallel with each other. The first, 158, talks about XAML and grid view and list view. The second talks about WinJS, HTML, JavaScript, and we'll talk about the WinJS list view and grid view. But let me show you what it looks like to do a multi-stage renderer. This, again, is from the store app, and this is going to start panning, and what you see here is that there's solid color, there's a title, there's a description, and there's the cost of the app. But what happens is afterwards, some of the more expensive elements are loaded. The ratings control is loaded, and the images are loaded. This is because they've developed it with, again, 2 stages, so they can hit that, 10, 15, whatever millisecond budget they need to deliver the speed of panning that they need. And so that if you don't hit that, by the way, you end up with basically white space as a user trying to pan through. It's not very pretty. But they can also deliver a really, really rich UI by deferring the loading of some additional content. And they can do this without a bunch of memory hit from having all, 6,899 apps preloaded in memory and all the image for those preloaded in memory. And they can do so without the responsiveness hit to page navigation and page load times and app load times by, again, having preloaded those 6,899 apps. So that's 5 scenarios. That's 3 design challenges. I've shown you a bunch of demos of things not going well, a bunch of demos of things going well. Everyone's going to need to apply this differently to their apps. The goal of this talk is really to talk about what you can do and the process you can follow early in your design process so that you can apply it uniquely to the apps that you're trying to develop. And so that you don't find yourself later on measuring performance late in the game and finding you've got problems, you've got a bunch of fragments of code that are running and you can't follow the causality path, and you've got a slow launch time that you can't improve, or you've got a slow panning that you can't improve very easily. Some key takeaways that you'll want to leave here with. Design that UX with prioritization in mind. Almost every one of the scenarios I walked through, I talked about prioritizing UI and delayed loading of content. Loading code only when needed for that UI is one great way of starting out from a great baseline and not regressing that baseline as you add more and more rich functionality. Smart caching that involves great UX transitions from stale content to live content is, again, a great way of developing consistently fast page navigations, app launches, and consistently good UX on your resumes. And then we talked about, especially for list view, or for panning and for resize and rotate, and some for page navigation, keeping those scenario-specific differentiators, budgets, and timelines in mind is really going to help you deliver a great app from the start. And then you can go and say, I'm going to go the last 10% by going and analyzing, optimizing once my code's done, but you don't have to spend a bunch of extra time at that point. So with that, there's a bunch of resources in here, and you can talk to me afterwards about which of these resources might be applicable to you. A bunch of talks. I encourage you to evaluate this session. I'd love to know how you felt about it. This, again, is the first time we've delivered this kind of content at Build, and I'd like to know if it's very useful to you. So with that, I have about 5 minutes to open up for questions, but then I'll be here afterwards to chat with any of you about specifics that you have. So, any questions? Yeah? So the question was, if you don't know the total count, is there a great way of doing this virtualization? So there's a bit of difference between data virtualization and actual UI virtualization. So if you don't know the entire count, then it's, I guess, that data virtualization that you're talking about up front. That's an interesting question. There's a lot of places where you can know the total count. Let's talk a little bit offline about your specific case, and then I'll make sure that if I can't answer your question, you got the right answer. Okay. And I apologize if I miss anyone because there's lights in my eyes. Any additional questions? Okay. Well, I'll be up here afterwards. Thank you so much for attending, and I hope you got something out of it.